In the last video, we discussed about the integral test, okay? So where if you want to know the integral of a series, then if the nth term of a series denoted by fx or an denoted by fx is positive, continuous, non-negative, continuous, and decreasing, then to check the convergence or divergence of the series, then you can check the convergence or the divergence of the improper integral. Okay, if the improper integral converges, then the series converges. If the improper integral diverges, then the series diverges. That's what we learned in the last video. Okay, also that result implied the p series test. That means if there is a series of 1 over x to the p, or you can say n to the p, then the series converges if p is greater than 1, and the series diverges if p is less or equals to 1. This was given by the integral test. Okay, this result was given by the integral test. Okay, so here we are going to learn a new techniques to know the convergence or the divergence of the series. Okay, because the techniques of the convergence or the divergence, we learned divergence test, right? Nth term divergence test. We learned the geometric series test and p integral test, p series test, and so many tests so far. But so some of the problem, these tests that you learned so far does not fit. So you need new type of result to check the convergence or divergence of that series. Okay, so the next one in this section 9.4 is the comparison series. Okay, so what does that mean? Comparison of the series is there is a theorem if an and bn both are positive. Okay, if all an and all bn, meaning a1, a2, a3, a4, like b1, b2, b3, all of them are positive, there is less than 0, greater than 0, and also all the terms, you see that the terms of an are less than or equals to the terms of bn for all n. So a1 is less than b1, a2 is less than b2, a3 is less than b3, and so on. Okay, in that case, if the bigger, you see that the bn is the bigger, the bn's are bigger than an's, right? Then the series of the bigger, if the series of the bigger terms converges, then the series of the smaller terms converges. And that's obvious, right? Because you know the convergence of the series is if the summation is a finite number. If the bigger summation of the bigger terms is a finite number, then the summation of the smaller term will be a finite number. Similarly, the next result is if the smaller term, the series of the smaller term diverges, then the series of the bigger term will diverge, because the series of the smaller term diverge means the sum is infinity, right? Then the series of the bigger term will also be infinity. Okay, in other words, if larger series converge, then the smaller series converge, and if the smaller series diverge, then the larger series also diverge. Okay, so if the bigger series converge, then you can the smaller converge. If the smaller series diverge, then the bigger diverge. But if the bigger series diverge, we cannot say about the smaller series. And if the smaller series converge, then we cannot say anything about the bigger series though. Okay, all right, let us see some examples here. Number 1, all these examples are taken from the book. Okay, test the convergence of the following series. Number 1 is 1 over 2n minus 1. Okay, let us say that let bn, this is, we denote this by an, let us say that this is an. Okay, bn equals to 1 over 2n only. So which one is bigger? Is an bigger or bn bigger? Bn is bigger, right? Because you see that an has 1 over 2n minus 1. Oh, sorry, an is bigger than bn, right? Then an is bigger than bn, bigger or equals than bn. Also, all the ans, so all the bn's and an's are positive, right? You see that all the an's and bn's are positive. Now, which one is the bigger series? An is the bigger series, right? So and bn is the smaller series, right? Does bn converge or diverge? The bn, and let me write down the and summation n equals to 1 through infinity 1 over 2n. This diverges how? Because you can write this as 1/2 and then summation n equals to 1 through infinity 1 over n, right? You see that the p series test, it has exponent 1 over n to the p. If p is greater than 1, it converges. If p is less or equals to 1, it diverges, right? and this diverges. So what diverges? The smaller series diverges, because you see that the series of the Bn diverge. So the bigger one is series of An. Hence, by comparison test, the series of the bigger term, that is 1 over 2n minus 1, summation n equals to 1 through infinity, 1 over 2n minus 1 diverges. So this is what we can say. Okay, since the series of the smaller term diverge, then the series of the bigger term must diverge. The second one applied there. You see that? Let us do another one. 1 over root n minus 1. Also let Bn equals to 1 over root n. Okay, then which one is bigger? Let's say that this is An. Okay, this is An. Then what do we get? Then An is greater or equals to Bn is greater or equals to 0, greater than 0, right? You don't need equals to, greater than 0. Greater than 0 for that n, right? For n is greater or equals to 2. That is true for that. Okay, so but how about Bn? Does the Bn converge? So that Bn is, but summation n equals to 2 through infinity. Bn is Bn equals to summation n equals to 2 through infinity, 1 over n to the 1/2. You see that it is the p series test. P series test say that if there is a series of 1 over n to the p, and if p is lesser or equals to 1, then this series diverges, right? Diverge. So this series diverges. The series of the smaller terms diverge. Then the series of the bigger terms must diverge too, because diverge means the series of the smaller term has the sum infinity, right? So the series of the bigger term must have also the sum infinity. Hence series of n equals to 2 through infinity, 1 over root n minus 1. This is the series of the bigger term. Also diverge by comparison test, right? Comparison test. That's all. Okay, guys. So let us do another example. Again, I'm taking all of these examples from the book. Okay, guys. So let us do this. So example number 3 is, does this series converge or diverge? Okay, so let us find out that. So suppose that this is An. Okay, this guy is An, and then let Bn is equals to, let me write down 1 over n plus 1. Okay, so which series is bigger? Is An bigger or Bn bigger? You see that Bn is smaller than An, because you see that there is 1 on the top of the Bn, but on the top of the An there is natural log of n, and n is greater than 2 or equals to 2. ln 2, ln 3. So you can write for n greater than 2, that is greater or equals to 3, you can say. For this we have An is greater or equals to Bn is greater than 0. Bn is always positive for n is greater than 2, right? And also what happens is n equals to 2 to infinity. Okay, 1 over, you can write n plus 1. This diverges by integral test. If you use the integral test, this you can do integral of 2 through infinity, 1 over n plus 1. Okay, and then you will get infinity there. Integral test. So the series of the smaller terms diverge, so the series of the bigger term must diverge. Hence you can write hence the summation n equals to 2 through infinity, natural log of n over n plus 1, because the smaller series, the series of the smaller term diverge, means the series of the bigger term must diverge. Okay, this diverges. That's what we got. Okay, let us do example number 4. Okay, in example number 4 you have n equals to 0 to infinity, 1 over n factorial. You see that what is 1 over n factorial means? It is like, what are the terms? It is like 1 over 0 factorial is 1 plus 1 over 1 factorial is another 1 plus 1 over 2 factorial is 1 over 2 plus 1 over 3 factorial is 1 over 6 plus 1 over 4 factorial is 1 over 24, and so on. This is what this series look like. Okay, so can we compare this with any another series? For example, you see that, so this is the first term, right? This is the second term, this is the third term, this is the fourth term, this is the fifth term, and so on. You see that? So you see that this is, let us compare this. This is the fifth term, this is the first term. Okay, let us write down another series. Let me write down 1. Okay, and then you can write again 1. Okay, and then plus this is the first term. I'm considering another series. Okay, the first term is 1. Okay, and the second term is, let's say, 1/4. Third term I want to write 1/9, and fourth term I want to write 1/16. Fifth term I want to write 1/25, and so on. Let us compare these two terms. You see that the first term are equal. The second term, which one is bigger? The blue one is bigger, right? So this is basically an. You see that? Summation an, that is the an, right? Summation an is that, and then I'm trying to write down that as summation bn. Okay, bn is 1/4, 1/9. Which one is bigger? That one is bigger. 1/6, 1/16. Okay, that is 1/6, 1/16. And then 1/24, 1/25. You see that here? So what you can say here, now you see that 1/25. So bn, okay, bn is 1/25, an is 1/24. 1, n equals to 0, n equals to 1, n equals to 2, n equals to 3, n equals to 4. That is fifth term. What would be the sixth term here? Sixth term will be 1/6 factorial, right? 6, because this is 2 factorial, 3 factorial, 4, 5, 5 factorial, 120. That is the 5 factorial, because 24 times 5 is 5 factorial. And what would be the next term here? 1/4, 1/9, 1. So that will be 1 over what? That on the bn, that would be 1/36. Okay, so what will be the other terms? After that, it will be 1/7 factorial will be 720. This will be 1/7 square will be 1/49, and so on. You see that? So here you can say that, now you can say that here, let bn equals to 1/n square. Okay, now you can compare that. For n is greater or equals to what? N equals 0, n equals to 1, n equals to 2, n equals to 3, n equals to 4. N is greater or equals to, because for n equals to 4, the an is bigger. Okay, from n equals to 5, n is greater or equals to 5. So for n is greater or equals to 5, after that, after 1/24 and 1/25, after these, okay, after that, the terms of an are smaller, right? You can write 0 is less than an is less or equals to bn. After the fifth term, you can write that. Okay, now what happens? But summation n equals to, let's say, 5 through infinity. Okay, 1/n square, because I said n is greater or equals to 5, that's why I'm taking 5 through infinity. 1/n square converges, right? Why? Because it is the p series test, because 1/n to the p, and then the power p is greater than 1 means it converges. This converges. But if you take from 0 to all of those terms, it is just like how many terms more? 1, 2, 3, 4 terms more. That still, or 5 terms more, right? 1, 2, 3, 4, 5 terms more, right? I think I should say greater than 5. Okay, n is greater than 5. For n is greater than 5, that converts. So you can write n equals to 6 through infinity. Okay, 1/n n square converges by p series, right? P series. So after that, the bigger series converges after that. So meaning that the bigger series will have a finite sum, because you see that for the first 5 terms, this is a finite number, and after the fifth term, the bigger series will have finite number too. So the total sum of the bigger series is finite, meaning the bigger series converges. Hence the smaller series converges. The series n equals to 0 to infinity 1 over n factorial also converges. So the smaller series converges because the bigger series converges. Okay, so this was a little bit tricky, but it is still, if you just think carefully, you should be able to do this. Okay, that was example number 4. Let us do another example. The another example is e to the negative n square. Okay, e to the negative n square. So what can you write about that? So you can write this as equals to summation n equals to 0 to infinity 1 over e to the n square, right? That's what it looks like. But how does that look like? That looks like if you plug in 0, you will get 1. If you plug in 1, you will get 1 over e. If you plug in 2, you will get 1 over e to the 4th plus 1 over e to the 9th and so on. You see that? So this is what you get. Now, let us consider another series. So this is an, right? This is like, that is like an. So this is like an. Let us consider another series. Let's say that so if you write this as, let's say 1 plus 1 over e plus 1 over e square plus 1 over e to the cube and so on. If you write, let's say let bn equals to 1 over e to the n, okay, then how that summation bn look like? Summation bn, n equals to 0 to infinity, that looks like 1 over e to the 0 is 1 plus 1 over e to the 1 is 1 over e plus 1 over e to the 2 plus 1 over e to the 3 and so on. Okay, now tell me, which series has bigger terms? If the denominator is smaller, then the series is, the whole fraction is bigger, right? You see that? For the first and second term, they have the same terms, okay? After the third term, this has smaller denominator, okay? So this is bigger. So you can say that for n is greater than 2, or so you can write n is greater than 1. You can write n is greater or equals to 2, no problem, okay? Because for n is equals to 0, it is 1. Both of them are 1. For n equals to 1, both of them are 1 over e. After n equals to 2 or bigger, for n equals to 2 or bigger, we write 0 is lesser equals to an is, so 0 is lesser equal to bn, okay? bn, you see that? No, an, 0 is lesser equals to, an is lesser equals to bn. Let me not write equals to for 0. So after the second term, after this term, right, all the terms of an are smaller because they have the bigger denominator. Then the terms are terms of bn, okay? And summation of n equals to 2 to infinity, the bn equals to summation of n equals to 2 to infinity 1 over e to the n, okay? Does it converge or diverge? It is a geometric series. Is a geometric series with what is r equals to 1 over e there, because you can add 1 over e to the n, which is less than 1. So summation bn converge. Summation bn n equals to 2 through infinity converge. So the series of the bigger term converges. You see that? The series of the bigger term. So series of the bigger term converges. So series of the bigger term converges. So hence the series of the smaller term converges. Okay. And you may be curious, our series is given from 0 to infinity, but the series converges from 2 to infinity. So the series converges from 2 to infinity means all the terms after these converge, right? Meaning the series, the sum of the terms after this is finite, but adding just these two finite number will become the whole series converge, right? So the whole series converge. You can add n equals to 0 to infinity converge, because after that converge means the whole will converge, because adding just the finite number, right? So by comparison test, you can say that summation of n equals to 0 to infinity e to the negative n square converges. So you can write like this. Okay, guys. So the next thing is this one. okay, this series. So suppose that this is an, and let us suppose that bn is sine, you can write this, bn is 1 over n cubed. Then for n is greater or equals to 1, sine, so you can write 0 is less or equals to an is, you can just write less than an, you can write less or equals to for nen, and then less or equals to bn, okay, because you see that sine square n is less than 1, and there is nq in the denominator is same, but on the numerator sine square n is always less than 1, right? So that's why you can write that. Since summation 1 over n cube 1 through infinity converts by p series test, because the n to the p and the p is greater than 1, right? So summation n equals to 1 through infinity, that an sine square n over n cube converges. Okay, so these examples are basically the example for the convergence or divergence of a series using the comparison test. There is another comparison test that we call limit comparison test. Okay, let me write the theorem for that, or the formula or the rule for that. Okay, what does it say is, if a sub n is greater than 0, meaning that all the terms of a sequence are greater than 0 and all the terms of bn are greater than 0. So both of the series are basically positive series, right? Series of the positive terms, I would say. And if the limit of nth term of an and bn equals to L, it is a finite number, finite positive number. You see that? Finite and positive. If the limit of the nth term of an and bn, you could write bn and an, not a problem, is a number L, which is finite and positive, in that case both an and bn either both converge or both diverge. Okay, so either both of these converge or both of these diverge. So that is called the limit comparison test. So I will present some examples of the limit comparison test in the next video. Okay guys, all right, thank you.